In this class, we will discuss about the factors affecting the rate or the speed of simple diffusion. The first one is gradient concentration is directly proportional to the diffusion rate, or you can also write in this manner concentration gradient. Concentration gradient is directly proportional to the diffusion rate. Now what does it mean? It means, here I have taken an example. This side, imagine 100 potassium and here 10 potassium. And the other side 30 potassium and 10 potassium. So right, so here we can observe there is a difference of the concentration in both the sides. But this side, 100 potassium on one side, 10 potassium this side, that means how much difference is there? The concentration gradient or difference is 20 potassium. Difference kanpista undi this side. Now this side 30 and 10 potassium, how much difference is there? 20 potassium difference is there. And this side there is a high concentration difference, and this side less concentration difference or less concentration gradient. So what is happening is, now in both the sides the diffusion is taking place from high concentration to low concentration. ఇక్కడ నుంచి హై కాన్సంట్రేషన్ నుంచి లో కాన్సంట్రేషన్ వైపు అయాన్స్ మూవ్ అవుతున్నాయి. ఈవెన్ దిస్ సైడ్ ఆల్సో ద అయాన్స్ ఆర్ మూవింగ్ ఫ్రమ్ హై టు లో సైడ్. బట్ వాట్ ఈస్ దట్ వీ హ్యావ్ టు నోటీస్ ఈస్ the speed of the diffusion this side is more. ikkada ఎక్కువ స్పీడ్ ఉంటుంది molecules movement. ikkada the speed of the diffusion is less because there is a less concentration gradient, so the molecules will be moving this side slowly. Now comparatively when you focus on this side, because the concentration gradient is more, the molecules will be moving, or these high ions will be moving very fast to this side. So that means what? More the concentration gradient or more the concentration difference, more the speed the molecules or the ions will be moving this side. Less the concentration gradient, less speed the diffusion of these ions will be moving. So that is what we have written in the first important point, which is the concentration gradient is directly proportional to diffusion rate. That means more the concentration gradient, more the speed of the molecules or ions. Less the concentration gradient, less the movement of the ions or molecules. Right. The next point is the diffusion pressure is directly proportional to diffusion rate. So that means what? High diffusion pressure is there, then the diffusion rate will be more. Less diffusion pressure is there, then the diffusion rate will be slow or less. Next, the third important point is the temperature is directly proportional to diffusion rate. Now let's understand by taking an example. Here I have taken two beakers, beaker A and beaker B. In both the beakers I filled with water. Now what I did is, in the both the beakers I added sugar. I added sugar, 1 spoon of sugar, imagine. Right, now what I am doing is, beaker A is as it is, but beaker B I am heating. So I am heating this beaker. Now what happens when I heat the beaker? I have raised the temperature. When I have raised the temperature, that means what? This here, the sugar molecules, whatever are there, they are getting some extra energy, right? Now because of this extra energy, they started spreading inside the beaker very fast. So the sugar molecules are moving very fast and spreading in the beaker very fast. So that means what? Here there is a diffusion of sugar molecules, but here in the beaker B it is very fast. The diffusion rate is more when compared with beaker A. Beaker A lo kuda diffusion jarugutadi. Here also the sugar molecules are moving from high concentration to low concentration. But when compared with the beaker B, the movement, the diffusion rate here is slow. Why it is slow? Because in the beaker A is we are not heating it, we are not increasing the temperature. So that is why the sugar molecules did not get an extra energy, and that is why they are moving very slowly. But in case of beaker B, because we have heated, that means in the beaker the temperature has raised, that means sugar molecules are getting some activation energy, extra energy, and because of that the movement of the sugar molecules is bit fast here. That is why the sugar molecules has spread in the beaker very fast and the equilibrium has also reached very fast. So that means what? When we increase the temperature, the speed of the diffusion is also increased. So temperature is directly proportional to the diffusion rate. Next one, permeability of the membrane. So imagine if the membrane is more permeable, that means more diffusion rate. For this, let me understand an example by taking an example. Imagine this is a plant cell wall. And next one is, this is a plasma membrane. Right. Now imagine the molecules have to move from outside to inside. Itla movement jaragali. So sodium is less here, 10 sodium, and outside there are 100 sodium. Now what happens, because the sodium is more outside and less inside, what is happening? The molecule started moving from high concentration to low concentration. They have crossed cell wall successfully. Sodium cell wall ni cross chesnayi, because cell wall is more permeable. Permeable means what? It is allowing the molecules inside. So now the sodium have crossed the cell wall and now they have to cross what? Plasma membrane. ఇప్పుడు ప్లాస్మా మెంబ్రెయిన్ని దాటుకొని లోపలికి వెళ్ళాలి, సెల్ లోపలికి. బట్ ప్లాస్మా మెంబ్రెయిన్ ఈజ్ సెలెక్టివ్లీ పర్మియబుల్. సెలెక్టివ్లీ పర్మియబుల్ మీన్స్ ఇట్ అలౌస్ ఓన్లీ సెలెక్టెడ్ సొల్యూట్స్ ఇన్సైడ్ అండ్ సాల్వెంట్. ప్లాస్మా మెంబ్రెయిన్ అనేది ఒక సెలెక్టివ్లీ పర్మియబుల్ మెంబ్రెయిన్. ఇట్ అలౌస్ సాల్వెంట్ని అలౌ చేస్తుంది, అండ్ ఇట్ అలౌస్ సెలెక్టెడ్ సొల్యూట్స్, కేవలం సెలెక్టెడ్ సొల్యూట్స్ని మాత్రమే అలౌ చేస్తుంది. Now what happened? Here a problem arised. Problem enti? Now plasma membrane is not allowing sodium inside. So that means what? By this example you understood that the diffusion of the sodium has been affected now. Ippudu sodium move avalekapotundi because plasma membrane is not allowing sodium inside. So that means what? It depends. The diffusion speed, the diffusion rate also depends upon the permeability of the membrane. More the permeability, more the diffusion. So cell wall is permeable, so that is why the rate of diffusion was very high. Cell wall ni cross chesne easy ga sodium. But because plasma membrane is selectively permeable, it is not allowing sodium inside. So that means what? The rate of diffusion is affected here. So that means what? The permeability of membrane is directly proportional to diffusion rate. More the permeability, more the diffusion rate. Less the permeability, less the diffusion rate. Next one. The diffusion rate is inversely proportional to the square root of the density of the substance. Now what does it mean? So here what you have to remember is, imagine if this molecule is one side. This is a molecule which having high density. Its weight is more. And this side you can see a molecule whose size is less, whose density is less. Right. Now out of A and B, which has the capacity to move fast? The substance B has the capacity to move fast. Substance చిన్నగా ఉంటే, దాని సైజ్ చిన్నగా ఉంటే, దాని డెన్సిటీ చిన్నగా ఉంటే అది ఎక్కువ ఫాస్ట్గా మూవ్ అవ్వగలదు. ద డిఫ్యూజన్ రేట్ విల్ బి మోర్. If the size of the substance or the molecule is heavy or large, then the diffusion, the movement, the rate of the diffusion will be slow. So that means what? Molecule size paina kuda the rate of diffusion is depending. So that is why the diffusion rate is inversely proportional to the square root of the density of the particle or density of the substance. Lesser the density of the substance, more the diffusion rate. More the density of the substance, lesser the diffusion rate. So these are all the factors affecting the rate of simple diffusion. Concentration gradient, directly proportion to diffusion rate. Diffusion pressure is directly proportion to diffusion rate. Temperature is directly proportion to diffusion rate. Permeability of membrane directly proportion to diffusion rate. But diffusion rate is inversely proportional to the density of the substance. Less the density of the substance, more the diffusion rate. More the density of the substance, less diffusion rate. And this particular law is also known as Graham's law.